Hello everyone, this is Abhinash and welcome to IMMORTal UNIVERSe. In this lecture, we'll see detailedly about the constructions and the working principles of the Coolidge X ray tube. Now let's get started. Coolidge X ray tube was first invented by an American physicist and engineer called William David Coolidge in 1913. This Coolidge tube made a great revolution in the medical field because in this tube we can control the electron emission and the X-ray emission separately. Okay, because of this reason these X-ray tubes made a great revolution. First of all, we'll start from glass envelope. Do you know why X-ray tubes are made of glass?
I think because of its transparency, we can able to see the components present inside the X-ray tube.
Yes, this is also the reason, but beyond this we have a main reason, that is, firstly, these glass tubes are good insulators. It does not conduct any electricity. And secondly, these glass tubes are vacuum tight. And thirdly, there will be no serious attenuation of the X-rays. Instead of glass, if you use any metal, it's going to be attenuate the X-rays and reduce the intensity of the X-rays. And fourthly, these glass can be fabricated into any shape. And fifthly, it can withstand enormous amount of heat without breaking down. Because of this reason, these glass are used to make X-ray tube. And Pyrex glass is used to make X-ray tube because Pyrex is the strongest glass. It can withstand enormous amount of heat. And that's it about this glass envelope. And now we'll see the construction of this cathode. Here in Coolidge X-ray tube, the cathode is made up of tungsten. So the reason for using tungsten is because of its high atomic number, that is 74, it can produce more electrons due to the thermionic emission. And also because of its high melting point, that is 3370 degrees Celsius, it can withstand enormous amount of heat during thermionic emission so that it does not melt down quickly. And here the filament configuration is like conical shape or flat. And this filament is fixed inside the most important component, that is called focusing cup. And here the focusing cup is made up of nickel, and for this focusing cup we are giving separate negative charge. So the reason for giving negative charge is to repel and convert the electron beam to the focal spot of the target. For example, if there is no focusing cup, what happens is the electron beam, that is the filament electrons, are going to be diverge. Because of this divergency, only some amount of electrons are going to interact with the anode and produce less amount of X-rays. If we focus the electron beam, all the electrons are going to be interact with the target and produce more X-rays. Okay, for this reason focusing cup is used inside the X-ray tube. Now we'll see about the constructions of the anode. And here tungsten is used as target in the anode. So the reason for using tungsten is due to its high melting point, that is 3370 degrees Celsius, it can withstand enormous amount of heat due to interactions of the high velocity electrons to the target. Okay, because of this reason we are using tungsten, and due to its high atomic number we can produce efficient X-rays and intensity of the X-rays are going to be high. Here, when this high velocity electrons goes and interact with the target, there will be production of enormous amount of heat, right? So to dissipate the heat quickly from the anode, water is supplied behind the anode. So here what happens is this water absorbs the heat from the anode quickly and reduces the heat. If the heat is not dissipated from the anode, there will be a crack in the target, that is called pitting. So to reduce this pitting, we are supplying water to dissipate the heat quickly. At last we'll see about the working principle of this X-ray tube. This X-ray tube works under Hot principle. If you don't know the Hot principle yet, I have done a detailed video at the atomic level. You can go and check it out in my comment box. I have given a link for that. Okay. So here I'll explain simply about this Hot principle. So what happens is, by giving thermal energy to the filament gets heated to the incandescence and emits electrons. That is called thermionic emission. By giving thermal energy to the metal, we can remove the electrons from the surface. When this electrons goes and interacts with the target with high velocity, X-rays are produced there. Okay, and this is simply about this hot process. And that's it about this Coolidge X-ray tube, and I think this video is useful for you. And if you have any doubts or feedbacks on this lecture, feel free to put comments on my comment box. I'll try to make it on my upcoming lectures. And if you want to get my upcoming lectures, you can subscribe my channel. And thank you.